Thank you very much for attending this talk. I have to say, I'm so excited to be here. And oh, okay, you can't hear me. How about now? Testing, testing. Can you hear me? Fabulous. Okay, right. So I'm so excited to be, attending and presenting in this amazing event. I have heard some really inspiring women so far, and I hope to, keep interacting with everybody. So let's start talking about my topic. So first of all, I would like to present myself. So my name is Marjory. I'm originally from Brazil, but currently I am working as a senior lecturer in applied artificial intelligence in Sheffield, Hallam University, the United Kingdom. My work, I'm working as a lecturer in Sheffield, Hallam, and part of my research, so I have been working in academic settings for around 20 years, and all my research has always focused on artificial intelligence, the theoretical part. So I have, supervised research students and worked developing new models. And my work focuses on creating new algorithms. So I evaluate the current ones. I apply the current algorithms to, specific application areas. And I evaluate how they behave and how they work. It's interesting, in the last, I would say, 5 to 6 years, it has become very, very evident that we have a whole new understanding of, intelligent systems, artificial intelligence, and its application. This is possibly due to having, more data available. So big data has a big impact on this, and also having more processing power. So we have stronger, more powerful computers that can deal with that specific, amount of data. And therefore we can use intelligent systems to, process and understand the data. This has caused some good, but also some bad in the world. It's very interesting that I was listening to some of the other talks, and bias is something that a lot of you presenters are talking about. So when we talk about using data, big data, huge amounts of data, it's very common that the real data will have some sort of bias. And what I wanted to discuss with this talk today is actually the popularization of the use of artificial intelligence, which in my understanding, it can be a good thing, but also the bad understanding and the misuse of this kind of techniques. And I'm going to explore more of that in a bit. Okay, so what we have, as I said, it's lots of data. So data is available, and that brings a few different issues. So you have problems regarding access to data. So you have lots of systems. People don't really understand what is happening with their own data. And then they, give their data willingly. So it's not unusual to have people sharing lots of personal things on social network and on, with their peers or their friends or whatever. And then this data is being used for these big tech companies. But not only that, you have a lot of people like surfing in the trend of using AI. And then using AI demands from the people who are developing new models a very specific kind of training. So it's quite easy to go to a Python platform or to a Microsoft one or a Google one, press some buttons and then getting some results for a neural network, a decision tree, a random forest, a convolutional neural network. And that sounds really amazing. And then that can, make people have more access to this kind of techniques. But understanding how they work would have a much bigger impact on the actual results. So the first thing that I want to talk is this misunderstanding of the concept. So artificial intelligence is everything that is intelligent. And then you have something called machine learning. Machine learning is a set of techniques which are inside artificial intelligence. It's not everything. It's not the same thing. Artificial intelligence is different from machine learning. Machine learning is a subset of techniques within artificial intelligence. And then you have deep learning, which is something also that became popular and became possible because of the deep learning of the big data evolution. So you have deep learning, which is something inside machine learning, and then you have machine learning, which is something inside artificial intelligence. So it's not uncommon to see people saying, oh, machine learning is different from artificial intelligence. Are you using this? Doesn't exist. So understanding what you have, I think it's a very important step. So the first step is understanding that you have lots of data. The data has bias, and you should be aware of the bias. Second step is understanding that machine learning is not the solution for all our problems. And then you have different levels of techniques that you can use within machine learning and then within artificial intelligence. So not everything that is intelligence is machine learning. And then deep learning is not something different from machine learning, okay? So this is the second point. Then you have lots of models. You have something, some of the techniques, they could be potentially well explored using this big data reality. And then you have lots of other techniques that can be used, not necessarily exploring the big data reality, but that could cause very much similar results without the need for creating those big, very powerful solutions that don't really deal with lots of variations in the data and so on and so forth. So the second thing, as I said, it's important to understand the whole context and then what you have available. But not only that, and this is the main point of my talk today that I would like to talk to you. So my main concern with the widespread use of machine learning specifically, which is what is mostly available on the solutions off the shelves that you can find online, is the misuse of the black boxes. And why do I say the black boxes are misused? Because the fact that you make this so accessible, anyone can go to Python, to a platform, to Google, to Microsoft or whatever, and then upload some data, press some buttons and get some results. But understanding what those results are is so important. And it's so important to understand how to fine tune or parameter tune the techniques. So more often than not, and I'm going to ask you this, and I would like you to reply on the chat box. Have you ever used any black box, any machine, any technique which is off the shelf that you didn't implement? Can you say yes in the chat box or no if you haven't? So no, Savita didn't use. Who? Everybody else, who used it? Can you tell me yes or no quickly? No. Oh, very good. I have a very good audience. So what happens is when you have a technique, for instance, you have a technique called neural network, which is something that is very popular. A neural network has several different parts on it that you could potentially. What happens is in the black boxes, in the off-the-shelf solutions, is that they come with what we call default settings. So they have predefined numbers for these parameters, for these, configurations of the technique. And what most people do, most people who don't have the understanding, the training to, organize this, they just use the default settings and then they get the results and then off they go, presenting that, selling that solution. And this is a very big problem because, the default settings, they are not there to be used. They are there to be changed. And then when you get a set of data, and you use the default settings, you are by no means optimizing the results of that technique. When you are not optimizing it, you can reinforce bias, you can be locked in what we call a local, optimum, so you don't have the full potential of that technique. But worst of all, when you don't change and you don't refine the parameters, you can create solutions that look fine. So they have what we call, high acceptance rate. They have lower errors, high accuracy, and so on and so forth. But they don't really classify anything because you haven't fine-tuned the technique. So this is a major problem. And I can give you some examples of what can cause, what are the impacts. So this is completely directly linked to the actual data set. So imagine that you have a data set of faces. So you want to recognize faces. So you want to say if this person is a female and then this person is a male. So for instance, you want to identify gender from faces, and then you want to use CCTV camera videos, okay, to do that. If you select a group of pictures or frames from a video, and then you do it in a very small, so you have a very small selection of videos, of pictures from these videos, you might have a very good result. You might have, very high accuracy. So the amount of images that are correctly classified is high. But if you don't know how to fine tune and you don't know how to analyze the results, in actual fact, you might be excluding the errors. Even though you have a high accuracy rate, you have a high acceptance rate, the errors that are caused, they exist, they might be linked to specific groups. So if you want to identify genders, so male and female, for instance, you might get lots of accepted, classified images, but the wrongly classified ones might an Asian background, or they might be Black people. And then you are reinforcing the bias. Another example, one of my research students, he's doing mining on judicial sentences. So if you want to classify, judicial sentences, so law stuff, you normally use processing language. So you natural language processing techniques, which is one kind of, machine learning model. Then what happens is, if you don't fine tune, if you don't optimize the techniques, the models, what happens is that you reinforce the words that are mostly linked, they are mostly present on the specific sets of sentences that you are analyzing. So you don't really understand what is going on with the technique. You don't really understand what is the relationship between the technique and the data set and the results. So if you just go to the black box, upload the data set, press a button, and then get the results, that's not enough. We should be, focusing on getting people to understand how to fine-tune machine learning models, so we could have better quality, solutions, and then everybody would benefit it. So society would have better solutions, people would be able to improve the quality of their solutions, and then the update process of everything that we are using can be easier as well. The default settings, they are quite, interesting. I have been to different talks where people would say to me, but, the default settings, they are there because they are the best optimized settings that you can get for the techniques. And that's really not the case, Some people, they had this illusion that the default settings, they were selected, but there is no such a thing as a good single configuration of a technique that will solve everybody's problem. So each technique is dedicated, it should be fine-tuned to the data set, to the problem that is trying to solve. This brings me to the next problem, and the next thing that I wanted to demystify today with this talk, which is the sensation and the feeling that people from other areas, apart from, computer science, computer engineering, looking at machine learning as the, panacea, the holy grail, the only possible solution that can, make our lives better, which is, again, absolutely not the case. So you have two issues with people from other areas. One of the issues is people thinking that they the technology, which is really bad, because they think that solution, which is very magical and very hidden and very complicated, which is not true, but they think that it's going to replace them in the workplace. This is never the case. Another thing that I want to demystify is the fact that, the current power that we have, the technological power, and then the dedicated solutions that really work because they went through the process of fine tuning. They solve specific problems. They are not there to solve, to become a human. They are not going to become, to replace human beings. That's not the goal. The goal is to have, specific tasks done really, really well. The other thing that happens is because people don't really understand, you actually have the opposite reaction. So people in higher, roles in institutions, being it public or private institutions, they see potentially, increase in gain in profit because they have, a more accurate, a more precise running of their businesses. So another example that I can give you is, in the Brazilian judicial system, they want to use a decision support system that does classification of sentences. So it gives you a suggestion of the outcome of the sentence to a judge, for instance. And this was done not following fine tuning, but the judges, they want to make their lives easier, even though this might have a really big impact on the lives of the citizens. They're opening those cases, so they don't really care about, what is the impact of this badly designed AI to the population. They don't really care about that. They want facility. They want to have everything made quicker. And this is a really big problem. So this is something that we must fight as well, as a group, as a team, as a community that, works and studies artificial intelligence, machine learning models, and so on and so forth. So just to wrap up my talk today, I hope you are following. The idea that I wanted to bring today was demystifying the use of AI. So AI is not going to solve everything. AI can be a very powerful solution, can be a very supporting tool, but it's not going to save everything and to deal with every single problem that we have. The first point that I wanted to raise is understand your data. So if you want to use machine learning, make sure that first of all, before you even get to the model they want to use, you must understand the data they want to use. So if you understand the data, if you are not this area, come and find someone, go and talk to that person, to the specialist, so you will understand the data. The second one is, do not use techniques that you don't understand. If you, obviously, you don't need to be a mathematician, a specialist on the workings around of a support vector machines or deep learning neural network, for instance, but you should understand the overall workings of that technique. That will give you understanding and power and knowledge to be able to do the next thing. Change the default setting. So you will be able to do the fine tuning, the parameter tuning that I like to talk to, my students, my people that I talk to, and everybody else. So, Paula, if you want to talk to me about that, I have a few, research on gender bias in data. I'm more than happy to collaborate with you to exchange some ideas. The next thing is be creative. Don't use what everybody else is using. Make sure that you know what is available and then, go and try, but always changing the default settings. The next thing is be aware of black boxes. Off-the-shelf solutions, they are very good, very useful. They can be used, no problem whatsoever with that, but they must be used with careful analysis and understanding. And then if you want, you can talk to me. I'm more than happy to, discuss these specifics. I am on Instagram. I'm going to post my profile on Instagram. You can find me there. You can find me on LinkedIn. You can find me on, Facebook. You can find me on Twitter as well. I'm always, at Prof. Marjory. I'm doing research on theoretical AI, not only machine learning, but other techniques as well. I'm more than happy to discuss, I'm very willing to, get involved with the social part of the ethical part of using AI, because I'm very worried about, this kind of misuse. just if you want to talk to me, get in touch. I'm more than happy to talk to you. And that's it. This is what I wanted to talk today. And thank you again for coming. And please enjoy the rest of the conference. It's amazing. We can meet lots of amazing women. And thank you very much for attending. Bye-bye.